Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam MAS 1. Modern Actuarial Statistics 1, exam of the Casualty Actuarial Society. An insurance company classifies its customers into three categories. 1. Good risk. 2. Acceptable risk. 3. Bad risk. Customers independently transition between categories at the end of each year according to a Markov process with the following transition matrix. As you can see, transition from a good risk to a good risk has probability 0.5. Transition of good risk to acceptable risk has probability 0.5. And transition from good risk to bad risk has probability 0. Transition from acceptable risk to good risk has probability 0.4. Transition from acceptable risk to acceptable risk has probability 0.4. And transition from acceptable risk to bad risk has probability of 0.2. Transition from bad risk to good risk has probability 0. Transition from bad risk to acceptable risk has probability 0.5. And transition from bad risk to bad risk has probability 0.5. Calculate the stationary probability of a customer being classified as a good risk. Now remember, stationary probability is the limiting probability. It's the pi 1 in this case. The limiting probability of ending up in a given state. And here's the solution. So we note that PII is greater than 0 for I equal to 0, 1, and 2. So there's always positive probability for any state of transitioning into itself, and that means that all states are aperiodic. Also, the process is irreducible because all states communicate with each other. In an irreducible Markov process with a finite number of states, all states are recurrent. In a finite Markov process, a process with a finite number of states, being recurrent implies being positively recurrent. Therefore, this process is ergodic. All states are aperiodic and positively recurrent. Let us denote the stationary probabilities of policyholders in state 0, 1, and state 2 by pi 0, pi 1, and pi 2 respectively, and this is standard notation. Now, I checked all the assumptions of the theorem that we're using about the limiting probabilities being solutions of the balance equations. I have never seen the Casualty Actuarial Society putting a problem with assumptions as satisfied. So I'm being very formal about this by checking the assumptions, because normally on the test you would just write out the balance equations. But I'm teaching you. I'm not just solving problem on the test. On the test you just write out the balance equations and do your job. So, for an irreducible ergodic Markov chain, pi j is the unique non-negative solution of pi j equals the sum for I equals 0 to plus infinity of pi I times pij, where pij is the probability of transitioning from state I to state j. These equations are called the balance equations, where the sum from j equal to 0 to plus infinity, well, and of course we have finite number of states, but this is just the general result, is 1. Note that if the transition matrix pi and p is finite, of the form like this, and the vector of stationary properties is pi, with pi 0, pi 1, and so on up to pi n, where we see that this matrix has n rows and n columns, so there are n states. Then these equations, also known as balance equations, describing probabilities are summarized in one matrix equation, pi times p is equal to pi. In this case, note that the states are labeled 1, 2, 3, not 0, 1, and so on. The notation with the 0 being the first state is the most common. That's the way the textbook has it. But in this case, they're called 1, 2, 3, so we write them for the states 1, 2, 3. And the balance equations are pi 1 equals 0.5 pi 1 plus 0.4 pi 2. Pi 2 is equal to 0.5 pi 1 plus 0.4 pi 2 plus 0.5 pi 3, and pi 3 is equal to 0.2 pi 2 plus 0.5 pi 3. Of course, we also have pi 1 plus pi 2 plus pi 3 equals to 1. And this is something to remember, that the balance equations are always linearly dependent. We can't say, oh, we have three equations, we're going to solve the system of balance equations and get the answer. No, they're always linearly dependent. And if you're doing this on the test, you would just write out the balance equations as you see here. Write out the pi 1 plus pi 2 plus pi 3 is 1, and solve. So this would be a starting point if you were doing this problem in a regular way on the real exam. From the third equation, pi 3 is equal to 0.4 pi 2. From the first equation, pi 1 is equal to 0.8 times pi 2, and therefore pi 1 plus pi 2 plus pi 3 is equal to 0.8 pi 2 plus pi 2 plus 0.4 pi 2 is equal to 1. So pi 2 is 10 over 22. And then pi 1 is 0.8 pi 2, which is 0.8 times 10 over 22, and that ends up being 4 over 11. Pi 2 is equal to 10 over 22, or 5 over 11. And then pi 3 is 0.4 pi 2, and that's equal to 2 over 11. The answer that we're looking for is the one about good risk. So pi 1, so it's 4 over 11, or 0.36363636, and that's answer B. Please remember, this is copyrighted material. The problem itself belongs to the Casualty Actuarial Society. The solution is mine. Good luck in your studies, and good luck on the